Okay, so let's go and begin today's webinar. So today webinar is going to be all about a discussion of the Hadoop platform and basically taking a scale of when to use Hadoop, when not to use Hadoop, and the primary applications where Hadoop can be used better, and also the applications where one should not consider Hadoop because Hadoop generally, with a buzzword today, has been considered can be used across everywhere. So today we are just going to uh, put a balance between how to use the Hadoop framework. So that's what we are going to discuss in today's session. And so with this, I'm Sagar, and I have more than a decade years of experience in enterprise architect. And prior to this, I also have a 5 years of experience in Hadoop technologies, and also I have 1 year of experience with Edureka. So regarding Edureka, I think most of you will be already aware. It's one of the leading online training providers, and also along with this, we also provide a 24 pass web support. So thank you all for joining the webinar session today. Thanks for each and everybody who have joined the session. And the next 1 hour is going to be a very interesting debate on Hadoop technology and seeing some use cases of Hadoop. So with this, let's go and begin today's webinar. So before even going and understanding now what about Hadoop, etc., I just like give a very small introduction of what is Hadoop. Okay, that helps you a lot. So since we have only 1 hour of time with us, so the first 30 to 40 minutes I might go over the theoretical aspect of the webinar, and the last 20 minutes I like to cover some of the use cases with Hadoop where primarily Hadoop can be used very much effectively. Okay. So maybe I can give a very small introduction on Hadoop even before starting what is the session is all about. So let me give a very small introduction of basically what Hadoop and why Hadoop is all about. So Hadoop is closely related to the big data domain, right? So that everybody is already aware of why we use Hadoop, because the primary intention of using Hadoop is because it is totally a framework which is used for big data domain. So prior to Hadoop, right? So what makes Hadoop one of the most important framework in the market today? So that is the answer we need to understand first, even before understanding when to use Hadoop or when to not use Hadoop. So the primary thing of anybody has to understand is why Hadoop, right? How come Hadoop become a very important perspective in the big data domain today? So to answer this question, so primarily what happens was, as big data means a big data is nothing, lots of data, right? As as we start accumulating more and more data, right? We started facing problems like the first thing, the data storage. So how effectively the data storage is going to happen, and also on the data analysis. So a typical RDBMS developer, I hope everybody can able to see the notepad, right? I just shared a notepad. Okay, yeah. So so before as we are discussing of why Hadoop, so as the data gets progress to means as an organization, when I might have started with a storage of 20 GB of data, right? So as my organization grows, and the data capacity also grows along with the organization, right? So in that case, what happens? So we need an answer for this, right? As as the data keeps growing, is there any system can accommodate how much data is going to come? So I can't define. It might be a 40 TB of data, or down the line it might go to 100 TB of data. Down the line it might go to 150 TB of data. Nobody is in a position to define, right? So that's what the problem started, right? A typical RDBMS cannot solve this problem because an RDBMS is fixed. We are talking about something called as totally and absolutely figure which we cannot come up. It might go to 500 TB, it might go to 600 TB, right? So that's the one problem. And next is the data analysis. So when we talk on the analysis perspective, so is it possible to take the complete 100 TB as an input? Right, so this is what the next question comes up, which I am never able to achieve with my current database problems, right? In the current database I cannot do this, or in current solution, it may be any solution, not only a database perspective, right? can I consider the complete 100 TB as an input, or can I consider the complete whatever the data I'm going to use as an input? If I say X amount of data, okay, so finally the bottom line is the big data put a very simple problem is, if there is an X amount of data, so can you store this X, and also can you do the complete analysis on X, right? So this was the biggest challenge, right? This is the challenge which was put forward to the complete industry. So that's what big data started creating the problem. The primary reason is the database cannot scale up. There's a limitation of every single person is who are using the database is clearly aware of why it cannot handle 100 TB, and we don't want to discuss on that also, because that's not the primary reason of using this, correct? Okay, so so in order to answer this, so we come up with a framework called as Hadoop. So that's where basically Hadoop came up in the picture. So it complete distributed data set. So that's the solution Hadoop came up, a complete distributed data set. So that's where basically Hadoop started discussing on it. So let's see maybe a internal understanding of how Hadoop is going to solve this. But this is what Hadoop was trying to solve. Okay, and this is what Hadoop has solved, and that is why we are using Hadoop. It gave us an answer of storing any amount of data at the same time of storing at the same time of doing analysis to any amount of data. Right? There is no such thing like restrictions. There is no certain restrictions on the big data technologies with Hadoop, right? And how it is achieved, let's see in today's session, right? So that's what I want to put forward first, what basically Hadoop is trying to solve, right? So it is a distributed framework, a completely distributed framework which tries to solve the big data problem, the problem which we discussed called as amount of data, and as well as the complete analysis of data. Okay, so that gives a very small introduction of what Hadoop is all about. So maybe next we can go over the slides and understand when to use Hadoop and when not to use Hadoop. Okay, is everybody clear on this? You're getting an understanding of what Hadoop is all about? Okay, fine. So okay, so as we discussed, so that's what basically Hadoop is all about, etc. Everything is fine. So the one important thing everybody has to understand today, what they think is that because Hadoop as a framework is able to solve all the problems, right? So it's not something we should use Hadoop for everything. Okay, because we have a solution like a framework called Hadoop, which can solve the distributed processing of data, right? So we should not conclude something like Hadoop is the solution for everything. So that's not the case, right? There are some scenarios you should not use Hadoop, and there are some scenarios you should use Hadoop, right? So let's consider when not to use Hadoop. So let's consider scenarios where we cannot use Hadoop, right? So let's consider real-time analytics. So Hadoop technically works towards the batch job processing of data. So when I say batch job processing of data, right? So a batch job is something which basically occurs in a batch of files. So if you want any live data analytics, so if you are coming back and asking something like, for example, a tutor data, right? A tutor data is a prime example of live data analytics. So a tutor is like a streaming of data where the data is going to be keep coming on, right? For a particular hashtag, the data is going to be keep coming on. So it's never going to stop. So that is one prime example of a live streaming of data, right? So in those kind of scenarios, Hadoop is not a suitable framework, but there are technologies like a Spark, etc., which is existing in the market today, will run on top of Hadoop to solve this particular problem. But Hadoop alone is not came up with a perfect solution so far for this particular streaming of data. We have Spark and we have something called Storm, so which can run on top of Hadoop to solve this, right? In recent versions of Hadoop, means current version of Hadoop is trying to solve these problems, the real-time analytics, but technically Hadoop is best suited for the batch processing. Okay, the current versions of Hadoop is now focusing towards solving these problems also. How we can target a stream of data, right? So even that is also they are targeting. So whenever I say a stream of data, means continuous processing of data is called a stream of data. So when I have a tutor kind of scenario for a particular, for example, a sport, right, a cricket or a basketball, so one can expect the data to be keep flowing at any point of time. Okay. Whereas if you are coming back and asking for a complete hospital and you are trying to find what's the total number of inpatients or what's the total number of outpatients, etc., all the things, right? So that is a batch processing. Nothing is going to change big time. Yes, one or two patients might come here and there, but not like a tutor. A tutor is something where a continuous streaming of data is happening. Okay, so real-time analytics is something Hadoop is not suitable. But as I said, the current version of Hadoop, right, 2.5 and 2.6 is having a strong support for this. There are a lot of technologies which is coming on, like primarily a technology called Spark, so which is heavily running on top of Hadoop now. Fine. So which is having a complete support of this. Maybe down the line in Hadoop, more versions of Hadoop, you can see the support of this also. But with the current versions of Hadoop, it's better to use with some other technologies like Spark or Storm to solve this particular problem. But Hadoop alone is very good for solving a batch processing kind of a job, right? So that's one scenario. Whenever real-time analytics come, you should not prefer Hadoop directly. You should have some other technologies running on top of Hadoop. Okay, that is one way, right? So as I was discussing, you can see Spark, right? So I was taking an example of Spark. So whenever a real-time analytics of data is coming up, right, you can use Spark. But again, Spark alone itself cannot give again a real-time analytics. So there is always some amount of gap should be there in processing the data, right? So even though if I say Spark, right, at least a 10 seconds of a delay will be there in the data, right? So if you see the real-time analytics, how it's going to come up today is, as per the current version of the Hadoop, there will be technology called Spark. Spark is just one way, okay? Even Spark is not mature. We have something called Storm. Storm is the most mature things, okay? So the one brilliant thing what Hadoop has done. So I have, you can ask me a question altogether, right? All of a sudden I'm telling something is going to run on top of Hadoop. So when I say something is going to run on top of Hadoop, so let's say I have a Spark or a Storm, okay? So this is keep going. There is no restrictions for this, right? And so we are coming up with a solution by telling, so Hadoop is not preferred for live analytics or a real-time analytics. Whereas you can use any one of these technologies on top of Hadoop, right? So now a question can come is that how is it possible for a Hadoop to adapt these kind of technologies? You use there's a Spark, there's a Storm, there's a Kafka, there's a Flume, there's a S3, and this is never ending. I can point something like some 20 to 30 technologies like this, which can perform live streaming of data, right? So now to answer this specifically, Hadoop is having a very brilliant component called as Yarn, right? So Yarn is one of the important component of Hadoop, which will turn according to the situation. So, for example, Hadoop's primary backbone is MapReduce. Okay, MapReduce is an algorithm which is basically coming as a built-in of Hadoop's algorithm, right? And we have all other things like Spark, Storm, Kafka, Flume, etc. All those kind of things, correct? So if you're going to submit the job as a Spark, the Yarn will take care of running as a Spark job. And if you're going to submit the job as a Storm, Yarn takes care of running as a Storm, right? So that's the advantage of using a framework called as Hadoop. Even though it is not having a direct support, it can still go ahead and support all the other technologies on top of running it because of the primary support of a built-in component called as Yarn. So Yarn's primary responsibility is to take care of running all these different technologies on top of it. So that makes Hadoop as a standard framework to use. Even though it's not supports directly, it has a lot of components which can run directly on top of Hadoop to support all these things. Okay, so that's one advantage of using Hadoop. So going back to the slide again. So coming back, so you can see here with the difference between a Spark and if used without Spark and if used with Spark, you can see a contrast difference happening in top of the performance ratio, right? So in a real-time analytics, so put forward again in the real-time analytics, it's always better to use a technology, something called as Spark on top of Hadoop or a Storm on top of Hadoop to achieve it. So that's what basically we're trying to interrupt. In the case of real-time analytics, Hadoop should not be used directly. You should be using some other technologies like Spark, etc. on top of it. Okay. Spark depends on the RAM if the data is very huge. Okay, Jay Prasad, Spark ancestor. So Spark internally takes care of the Jay Prasad. Spark is having a concept called RDD and the spillover, which takes care of it. Fine, Jay Prasad. So when you go over the Spark internal architecture, you can get a better picture of it. How Spark is going to handle this. Fine, Jay Prasad. Okay, Spark is okay. So RDD is something a resilient distributed data set, which I feel completely outside the scope of today's webinar, Jay Prasad. I request you to contact the support team on the information on Spark, so you'll get a better picture of it. So fine, Jay Prasad. But to put in a very simple definition, RDD is nothing called a resilient distributed data set, which can recover from itself on any crash. Okay. When Yarn supports Spark, Flume, and others, do they convert all to MapReduce? Definitely not present. As I said, when you submit a job as a MapReduce, fine. When you are going to submit a job as a MapReduce, it is going to run as a MapReduce. When you're going to send a job as a Spark, it is going to run as a Spark. It will never convert everything into MapReduce. Fine, Prashant? Fine. Okay. So how Hadoop supports? That's what Yarn is a component of Hadoop, Prashant. Yarn is been built up to handle things like that. Yarn is smart enough is going to handle it. That's what Hadoop is trying. So Hadoop and Yarn is not different. Yarn says if you give any job on can run on JVM, it can run. That's all. Yarn can run any job which can run on JVM. It has been developed like that. Fine, Prashant. That's the ultimate aim of using a framework called Hadoop, right? So, etc. All the things, whatever it is, if anything is going to be run on JVM, Yarn will support. As simple as that. Okay. How important is to learn Java to get big data? Java is one of the background programming languages which has been used with Hadoop Venkat. But primarily, I can say only one thing is there are technologies which is coming like Scala, everything, which is again playing a very major role even compared to Java. So it's not like complete Java domination, one can say, because Spark and all is something which has been developed completely with a technology called Scala. Okay, so but knowing Java is going to be an added advantage. Okay, fine, Venkat. So it's but as I said, when you join the course, we'll also provide you all the support on etc. Okay, I have heard Python is also used as scripting language. Yes, Chetna, but Java is having a very strong API. So that's the reason you will be watching Java used a lot compared to even Python. Okay, so you might see a lot of jobs will be running in Java primarily because of the API it is having. Okay, because Mahout converts all jobs to MapReduce. Mahout 1.0, yes, not Mahout later version. They stopped supporting MapReduce, Kashish. Okay, Core Java is enough for Hadoop? Definitely enough. Ashutosh, Core Java is more than enough. Okay. And also one more thing, Hadoop is not a replacement of the existing data structure. Means the thing is, whenever you're going to fetch the data from the front end, it's always going to come from database only. So what you have to do is that after doing the big data analytics, you're going to transform your data to database. So nothing big is going to change in that perspective. Okay, it's not something the applications need to completely change to use Hadoop. You can still fetch your data from the database. The only added advantage is Hadoop takes care of transforming your data to the database. Okay, as simple as that. Obviously, Elasticsearch better compared to Hadoop. Okay, Padmanabhan, Spark supports Elasticsearch and Spark will run on top of Hadoop. So there is nothing like Hadoop is going to be the base and everything can run on top of Hadoop. So that's what I'm trying to put forward. Okay, maybe I can just show you the Hadoop's. I just show you the Hadoop's HDFS how it looks like. So before proceeding to next of the slides. So basically, I'm just going to show you how an Hadoop shell is going to look like. Just to give an indication of how basically an Hadoop looks like. Okay. So whatever I'm sharing is basically one of the Hadoop clusters. So I hope you are all able to see. So this is one of the Hadoop cluster, a single node cluster. Okay, where you can see how the Hadoop clusters is going to be. So it's like a normal file system. There is nothing special like an it's nothing like an new kind of technology and all. How a normal file system looks, the same kind of file system. Okay, so it can process any file, either it may be a normal file or it can be an image file. Probably I will show you a demo on both how to process a normal file, as well as I will show you a demo of how to process an unstructured file like an image. Okay, probably I will try to show you a demo on both of the MapReduce. In next 10 minutes we will start on the demo of how they look like, right? So but the file system of the Hadoop, if you look like, it's exactly looks the same as a typical how your normal system looks like. The only difference between your normal system and this is distributed. The data which is coming here can be distributed across multiple machines. Okay, that's the one of the most important thing. Okay, so apart from that, it's absolutely normal file system. The only thing is the data is absolutely is distributed in the format of blocks. Okay, smaller section of blocks. So that's one advantage we can use in Hadoop. Okay, so maybe I can show you a MapReduce algorithm for a normal text file. Also, I can show you one of the MapReduce algorithm which can be used for your image file. I will show an example of both how to use it. Hadoop can be used effectively for a structured file as well as for an unstructured file. Okay, fine. So, what's the role of J2 in big data? As I said, Ashutosh, the Java EE frameworks, everything remains as it is, right? You're going to still fetch the data from your database only to the front end. The back-end processing of data only is changed to a greater extent. Okay, that's what is my thing. So is it like Informatica? It's more than the Jay Prasad, because there is nothing like restriction in Hadoop. As I said, the cluster can go to any extent. You can extend your cluster to a very greater extent. Okay, fine. Yeah. Did Hadoop require some pre-knowledge? No, nothing like that, Vishwas. It just acts as a file system, so it can just. It's a normal file system. That's all. It is distributed. That's all. Okay, as simple as that. What are these in tables? The database table names. It's completely, you have to come out of your database, Chetna. It is a normal file system. It stores the data in the format of files, not as tables. Fine, Chetna. So you have to remember it as a files. Okay. Fine, Rizba. I hope you have answered your question. Hadoop is some of the frameworks which cannot be learned as it is from the book, just like that. Okay, so it completely depends on a lot of complexities, etc. It's not like some frameworks like it's not like a language like a Java or a Scala or a Python where you can go and start as it is, right? You should have some level of knowledge, at least some prerequisites knowledge, like understanding the distribution of the file system and some level of knowledge on Linux. Okay, basically it requires all of kind of things. Okay, fine. So unless or until if you are going to have only a better understanding of Hadoop, so then only you should start using Hadoop for production. Okay, otherwise you should never use Hadoop for production. So it's always, even to start Hadoop, to study Hadoop also, right? It's not that much straightforward to use. Okay, so now let's coming back to this relations, when to use Hadoop, right? We have seen when not to use Hadoop. So let's say some of the scenarios when we are going to use Hadoop. So similarly, so we are going to use Hadoop, as we already discussed. The primary reason of using Hadoop is whenever the data size is expected to be very huge, right? Where the data is going to be exponentially growing, and you can also perform data analysis on anything. It means you can perform the data analysis on structured and semi-structured and unstructured. Basically, you can do a data analysis on anything, right? And also for future planning of data. So for example, if your organization is having 10 TB of data and you are expected to grow to a very greater extent, right? So Hadoop is a perfect solution for that because it can scale very much in a very good distributed way. Okay, so let's go back and let's do a small MapReduce example now. Let me show you a small MapReduce example. So technically, I'm going to show you an example of how to process a structured data, and also I'm going to show an example of how to process a totally unstructured data. Okay. So meanwhile, I'll take some of the questions. Is there any major changes in Hadoop 1.1 recent releases? There's a complete change. It's not even a major change. There's an absolute complete change. Fine, Ravi. There's a complete change in the releases. Okay, I want to perform dimensional production of images. I'm going to show an example of unstructured data with images, Kashish. So I'm going to show an example. Okay. Apart from prerequisites like Linux, we should have now before starting learning about what is the way to learn it. So Vishal, that's you can always join the Edureka course. We will guide you the exact way of how it can be done. Okay, we will provide you the nice knowledge on basically how to handle most of the things. Fine, Vishal. I just show a very simple MapReduce, then I will go for a very complex way of showing the MapReduce example. Next example, I will take you go through one of the unstructured files of using Hadoop. Okay, so first thing I'm going to use a very simple MapReduce example of showing how easily MapReduce can be done with help of Hadoop. So MapReduce is one of the data analysis algorithm which is coming inbuilt with Hadoop. Okay, it's one of the frameworks. So as I said, you can broadly classify into your Hadoop into three things. So one is something called as data analysis, and one is something called as data storage, and one is something called as your basically data science. Okay, so data storage is something where the data loaded into HDFS, right? So we talk about how to load the data into HDFS, etc., all those kind of things. So data analysis is something where we are going to do some processing of data. So whatever the data you store distributed, you are going to do that. And data science is something where your machine learning algorithm comes up in the picture, like Mahout, etc., rest of the things. Right, so this is where your Mahout, machine learning, and etc., all the things. But the most interesting thing is the Spark can be used in all the three. Okay, Spark is one of the most important features which can run on top of Hadoop, and it can basically solve the problems of all the three in one shot. Okay, so I'm just going to take the processing of data, which basically the initial way of processing data is a MapReduce algorithm. So I'm just going to show you a MapReduce algorithm, how Hadoop runs. I'm just going to give a document to Hadoop and trying to find basically how many words has been repeated. Okay, so once we did with that particular application, next I will take you a completely unstructured data. Maybe we can take some 10 images and try to find which image is duplicated. Okay, with the help of your MapReduce algorithm, right? So I'm not going to discuss much on MapReduce algorithm. Just maybe I can give a smaller introduction. MapReduce algorithm is just nothing a concept of mapper and reducer process. So when you say mapper and reducer process, the data will be split parallelly into multiple smaller sections, and each smaller section will be processed separately by a mapper. So once all the mapper has completed its process, the data will be combined and given to the reducer. So reducer is the person who is going to take all the data and process and finally going to produce a result. So for example, in this particular thing, so let me take your distributed file system. So this, sorry. So if you look at this particular data set, right, so it's just a normal data set, which is like a file system inside your Hadoop. So what basically the mapper and reducer does, so I'm telling you in a very simple way. So mapper is something which is going to run in parallel. So for example, each and every line can be given to a separate mapper on the least scenario. On the very least scenario, so what are the line you have 5 lines, right? You can ask mappers to start processing all the 5 lines. So that's why Hadoop is so much powerful. So if you have 5 lines of input, you can start 5 mappers and all mappers can run parallel. And you can go and means you can go and suggest what your mapper should do, right? So all you have to say is that you have to write a code and tell back what the mapper should do. So that's all as a developer you should say, right? So even if you're going to have some let's consider 1 lakh record, or maybe if you're going to even have some more than a lakh record, right? Even in that kind of scenario, if you look back, you can run any number of mappers you want. Okay, there's nothing much, there's no restriction like you should have only this much number of mappers. Okay, based on the availability, Hadoop can provide how many mappers it can based on the system's availability, etc. So that processing 1 lakh lines or processing a 10,000 lines, instead of processing in a sequence way of going line by line, so Hadoop queries can process everything parallelly. So it can split 100 lines into 10 lines each, and you can start working on 10 lines. So once all the 10 lines has been done, so once all the parallel process has been done, the output will be collected, and given to a final section called register, where the final section of the output will be done. So for example, in our particular scenario, each and every word, for example, if you had 5 lines, and each and every line might add a word called hello. So hello might have repeated in each and every line, right? So once all the mapper does this process, the reducer steps up and basically combines all the hello and says, okay, that you have repeated for 3 times. So that's how basically mapper and reducer works. So whereas a mapper takes responsibility of running each and every smaller section of data, whereas a reducer takes responsibility of combining the mappers and dumping the data. Okay, fine. So where mapper and reducer runs, everything runs as part of your Hadoop cluster. Okay, a cluster is having a master and slaves. So all the mappers and reducers runs on slaves. They run here. Fine, friends. They basically run here. So that's what their primary intention. They're going to run here actually. So if basically say, for example, if I'm going to execute the same job, so let me open up the Hadoop shell and let's execute the same job. So maybe after this example, I can. This is a complete structured data, so very simple operation. The next thing what I'll be basically going on is, after this particular example, I'll just show you the image files, okay, how the image file works, etc. all the things. So just I'm basically executing some of the basic Hadoop commands so that it makes sure the data is there, etc. all the things. So I'm just making sure the input file and output file, everything is existing. So that's all I'm doing. There's nothing special in this. So let me run the job. Okay, so I'm going to run the job of Hadoop. Since it is a Java program, so everything will be part of a jar file. So I'm just running as a jar file. So just I'm trying to process all the words, and I'm trying to find how many times each word has been repeated in the duration. Okay, the same thing with Spark will finish faster. Okay, it will definitely finish faster compared to this. So that's the advantage of having Spark, because Spark runs everything in memory. Okay, so basically when you look back and see the sequence of output, so when you go back and see the output now, everything again comes as part of the HDFS file system. Okay, when you see your output, it basically says it has processed the complete data which has been provided. This data can be of any size. That's what the point I'm trying to say. As an example, we have taken only less data. Even though it's going to be a data of any size, it's going to perform in the same way. Okay, because in a typical production system, you have a large cluster which is expected to run faster, right? And it basically tries to tell us each word has repeated how many times. Okay, as simple as that, a very simple algorithm. It's a very simple concept where we are basically running the things parallel, even in storage as well as in processing, right? Maybe the next example, I'm going to show you completely on unstructured data, something called as images, how we are going to process the images. Okay. So Spark is for streaming data. Does it perform well for data which is not live stream? Spark is the only best solution currently we have for live stream, Kashish. The current technologies, the Spark is one of the only best technologies which can perform live streaming. Apart from Spark, nothing can perform live streaming better than Spark. No other technology currently in the industry can perform equivalent to Spark, and no other technology is having a growth equivalent to Spark. Fine, Kashish. So it will perform. Okay. So going back to the slide again, and so another usage of the reason for using Hadoop, yes, it can be used with along with multiple frameworks. So it can be used with Spark, it can be used with Python, it can be used with MongoDB, etc. It generally can be used with lot of things, right? Okay, right. And one more thing, Hadoop itself is having something called as internal SQL query tools like Hive, etc. Okay, so Hadoop basically uses a query-based technology, something called Hive. Hive is the most popular wise SQL query-based which we have. And again, as I said, that there is something called Spark SQL, but Spark SQL is something again going to run on top of Hive. Okay, and so once the moment you join the course, we'll be taking you all these things, what basically an Hive query, etc., all those kind of things. Okay. If you are using the SQL table as input file, in what format is the map reduce perform? So if you are using an SQL table as input file, Sridhar, we have something called Scoop. Scoop takes responsibility of transferring the SQL table data into HDFS. So from there, map reduce picks up. Fine, Sridhar? That's the thing. Difference between Spark and SAP are completely different, Jayaprakash. Spark is something which can be used along with Spark can be used for normal processing. Spark can be used for streaming. Spark can be Spark is something can be used for machine learning. Spark is totally different. It's not in a smaller perspective. Okay. But Hive does not handle unstructured data. So yes, unstructured data I'm going to show you, Kashish. As I said, I'm going to show an example of unstructured data. Okay. Hive or Pig cannot handle unstructured data. Okay. If you want to handle unstructured data, you must only use MapReduce. There is no other option. Okay. Yeah. What's the use of a Flume? Flume is again one of the technologies which came before than Spark, means for processing live streaming of data. In our course, we cover Flume too. We'll have a concept on Flume telling you how the live streaming of data can be performed with Flume. Okay. So about Storm compared to Spark, nothing much. Only one thing I can say: Storm is more matured in streaming. Spark is definitely fastest growing technology, but Storm is more matured in streaming. But Storm is only supported for streaming, and Spark can be used across everywhere. Okay. Spark is better than Flume in processing live streaming. So to everybody, I think there are a lot of questions coming on Spark. So what I suggest is, one thing I can tell you all is that Spark is the better in everything. You can't compare anything with Spark because this is the one of the fastest growing technologies in the world. And for more questions on Spark, I request all you to go to the Spark webinar on the same. We have a separate Spark webinar. You can request the support team about Spark. Okay, so please okay, so please verify with the support team, they'll understand. But definitely there is no comparison with Spark. Spark is always the best, better framework compared to everything. Okay, so just even going to the next or to the end of the slide, I'll just show you how to process unstructured data even with Hadoop. Okay, so now let's see. Basically, I'll just take you the input folder. It means is this Hadoop Developer course, you're not going to cover full concept of Spark. Hadoop is something different. Spark is just a smaller part of Hadoop, Ravi. Spark runs on top of Hadoop. Like Spark, there are a lot of technologies running on top of Hadoop. Hadoop is a very big technology. Spark is one of the framework running on top of Hadoop. Spark is running on top of Hadoop. Mahout is running on top of Hadoop. Storm is running on top of Hadoop. Okay, there are a lot of technologies are running on top of Hadoop. So Hadoop is like an ocean. Okay, so you have to understand that. Okay, that's a different call, Ravi. Okay, Spark is just one of the thing. Yeah, you can say kind of a plugin, yes. In a way, yes, but in a broader perspective, it is different. In a way, for understanding purpose, yes, you can always say that. So even before going towards the end of the session, so let me please tell if there are any noun followed process for testing Hadoop applications. We cover in the course, we cover also on testing Hadoop applications, Padmanabhan. There are a lot of ways of testing Hadoop applications. There's something called MR unit. It's a very good concept where one can effectively test Hadoop. And there are a lot of other things too. Right? But MR unit is one of the best way of handling the Hadoop test units. Okay, so let me go for one final example before we wind up. So let me show you this example too. So now let me go into, I'm going to show you some of the fine. So these are the images I have. Okay, so technically, basically, I'm not going to go completely into the code. I'm just going to show you how much easily Hadoop can start off with your unstructured data too. Okay, I need to start with the basics of Hadoop. From where do I start? Chetan, I suggest you to join the Edureka course. We have a proper guidance from how to start Hadoop, from the basics of like Java, Linux, everything. Okay, we provide in all the things. Fine, Chetan. So what I basically I'm going to what I'm going to basically do in this particular map reduce example is, so I have a lot of things here, right? So in this, if you closely look at, right, this is one of the examples which is going to handle a complete unstructured of data. So if you look back at this particular example, all the flowers are of different size, except the three flowers. The flower 1 and flower 2 are of same size. Okay, and again everything is of different size. So what basically I'm trying to give to Hadoop is I'm telling the location of where the files are available. Okay, so basically I'm going to the input files. Okay, so let first of all we'll put the input files into the application, so that so let me dump all these input files first. So all these examples which I'm using is also will be shared, so one never needs to worry about all these things. Okay, all the examples which we are using will be shared, so you can get all these examples to practice and the same. Okay, so there's an images folder in my HDFS. So basically I have dumped all my flowers, etc., whatever I have discussed, whatever I have shown into my HDFS cluster. This is one advantage of using Hadoop. You never need to say about what is the data type, etc., right? The same thing you can't do in database just like that. You need to say whether it's a blob, etc., all the other things. Okay, so all the input images files has been dumped into my HDFS cluster, so which has been showed here. It's fine. And also I'm going to give one more file. Okay, uh, so let's go back. Also I'm giving the URLs of each and every file. Fine. So now basically I'm asking Hadoop process, these are the URLs. If you go to this particular URLs, you will find this particular image. So for example, let's go to this particular URL. You will find the particular image in the byte format. So that's what I'm telling to Hadoop. If you go to a particular location, you'll get each and every file. So go through each and every file and finally output me only the URLs of the images which is unique. So basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Out of 12, I'm expecting the output only to be 10, because flower 1 and flower 2 is of same thing, right? So if that's the case, let's go and execute this. See how smartly it's going to run it. Basically I use an encryption algorithm inside. Okay, so let's say so I'm just going to run it. So let me go and run it. You can always look back at the algorithm whenever you want. So I'm running this. So if you look inside the algorithm, it's basically an encryption algorithm. I can just show you the algorithm because of the shorter version of the time we can't cover much, but we are going to share this particular thing to you so that so basically if you look at the corresponding mappers and reducer class, you can see the MD5 encryption algorithm will be used. The MD5 is one of the most heavily used algorithm today in the market, and we use a encryption on them. We use a message digest algorithm which except for takes the mapper class. What basically we do is that we use the message digest algorithm to get the information of the images. We convert into a particular hash format. So once the movement we convert into a particular hash format, and from there basically we try to identify how these images are getting matched or not matched. Okay, it's very smart encryption algorithm has been used internally inside. Convert the image into MD5 hash and get into this. So that's what we're basically doing inside. Okay, so now when you go back to the output, so let's say user Edureka. So flower 1, flower 2, out of this it has to execute. Can you explain what exactly hash format? Hash format is just hash is basically one of the ways to handle the data effectively side, because it's image, right? We convert everything into bytes, but how to uniquely identify these bytes are different from other bytes, so we'll convert them into an hash. That's the use of using something called hash. Fine, Sai. Okay, so a lot of algorithms internally can be used. I use one of the algorithms. So let's go to the output. So the output basically is coming up. Sorry, let me see the location of where the output is coming up. The location of the output is coming on /sequence/output. Okay, so /sequence/output part 3. See here, it knocked off 2 files. It says only flower 2. The input is flower 1, flower 1 and flower 2, right? It knocked off. So it's only 10 now, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 from the 12. How smartly it has handled the unstructured data, right? Right. So here the important thing is that the map reduce still remains same as it is. Only I have added a new algorithm internally, right? The map reduce still remains same. So that's the beauty of using an Hadoop framework. The mapper and reducer still remain same. The code, it is Hadoop is asking what's the code to execute. While executing the code, I am using some of the smartest image algorithms to do on the same. Okay, as simple as that. As is this hash algorithm? Yes, Sanjay, it's an hash algorithm, and I using an MD5 hash algorithm internally. Okay. So there are so many tools works on Hadoop. Is Spark enough to get a Hadoop job quickly? Yeah. Spark and Hadoop will help you a lot in getting your career very much faster, Prashant. That is guaranteed. What is the second column in out? Oh, Sanjay. So basically, what happened is that uh, in the output, this is the hashing. We are telling this is the hashing code generated for each and every image. Only the unique thing should be taken. That's what the hashing has been done. That's what the hashing algorithm has been done. Hadoop internally understands the file with the help of this hashing. That's what the algorithm has done. Okay, so the beauty is for a structured file as well as for non-structured file, the algorithm remains same. So that makes Hadoop's standout MapReduce framework, right? So coming back to the slide, so as I said, you can always join the course. We have a very good support team who's 24/7 support, and we have a quiz program. And basically, we also have a project work. And you can always take the project work at the end of the thing to make sure uh, you are getting very good hands-on experience too. Okay. And coming back to the course topics, so these are the complete course topics we'll be covering on. We'll be covering on the basics of big data Hadoop, then architecture, the complete end-to-end architecture, then the MapReduce framework, and going on a complete advanced MapReduce framework, then explaining what is big Hive, then finally finishing off with Hive and HBase and the project. Okay. So question time. So I can take some of the question. So Hadoop takes file as an input and give output as a file. Yes, Manish. That's why it is called as Hadoop distributed file system. That's why the name is called as a file system. Actual use of Hadoop is others. They are one of the users, Devdatta, and there are a lot of users for Hadoop existing in the market today. Is the algorithm available on LMS for big data and Hadoop class? Yes, Kashish, it will be available. Okay. Thank you, Amit. Thanks for the feedback, Amit. Thank you very much. Is this domain advisable C++ programmers? Abhilash, currently there is no support for C++, but you can. I mean, sir, we will provide enough support on Java also to understand how Hadoop works. Okay, so don't need to worry about that. What is the Hadoop architecture setup is done in. So what basically, Ravi, what we are going to basically do is that when you join this particular course, we will give you a VM. Okay, so which takes care of complete end-to-end for you. You don't want to struggle anything on the installation part, etc., all the other things. You can just, we provide a very nice VM for you. Okay, and it helps you a lot. And also regarding the course related things, right, I always request you to contact support. They are going to guide you in end-to-end of what this course is going to have. Fine, Rabi? Suraj, I request you to go through the video again. Fine, the video will be uploaded. Please go through the video, Suraj. You'll all get this recording, and yes, you all get the recording and the practicals. Please contact the support on the same. To learn Hadoop, I need to join Java and other technologies. We will provide you guidance on Java and other technologies, Gaurav. Don't need to worry about it. Just join the course, we'll take up. Can you simply tell us the architecture? The architecture is something, is a concept of master and slaves, Rabi. So it's nothing, it's simple. If you give 30 machines, it will take one machine as the master, rest all 29 machines as a slave. Okay, we use CentOS, Ravi. Which is better, MapReduce or Spark? Depends on the requirement, Rahul. We cannot say which is better. Depends on the requirement. There are some cases MapReduce is better. There are some cases Spark is better. You have to contact the support team, Suraj. Please contact the support team on the same, and they will send you the links, etc., all the things. Ravi, more details on the internal architecture. I prefer to join the course, Ravi. Is that fine? So there we'll be explaining in full-fledged detail of the complete course or the architecture, etc. Is it fine, Ravi? I hope Rahul is your question answer, I think, right? No, Ravi, the thing is that we have a complete, see, if you look back on the course topics, we have a complete 2 sessions on Hadoop architecture. It's a complete 6 hours of session. So that's the thing I am trying to say. Okay, and also you can you can contact the support to get some there are some knowledge on Hadoop architecture also suggested on the same. The thing is that Hadoop architecture itself is 6 hours of session. So that's the point I'm trying to say. If you want to perform image reduction, should I use Mahout to work on MapReduce level? You can, Kashish. You can do it, yes. You can do it. Hadoop is behaving like ETL, and Kiran, ETL is something which you have to say what is the input and output. I just dumped the image file directly into the Hadoop file system, right? So it was not asking me any questions. It taking care of the ETL system internally by itself. Frankly, that's the advantage of Hadoop. Fine, Kiran. So it does all the ETL process internally by itself. That's the advantage of using Hadoop system. How many years of experience you have in Hadoop and Bit? I have around 4+ years of experience, Ravi. Devdatta, so there are different courses. For example, Devdatta, the course is actually targeted towards the end-to-end for the engineer as well as for the fresher and also for the senior person. So that's how it has been targeted. Prior to this, we also have support for Hadoop Architect too. Like there's an Hadoop admin course too. If you want a complete picture of deeper understanding of Hadoop, we have a course for Hadoop admin too. Fine, Devdatta. How to get started with Mahout? I have already attended Big Data and Hadoop classes. I prefer join Mahout course, Kashish. Else, you can also look into Apache Mahout website. They have a very good documentation. You can use a book called as Hadoop Definitive Guide, Sai. There's a book called Hadoop Definitive Guide. Instead of files, can assign database as input? No, you have to convert the database with the help of Scoop. Scoop converts the database into a files, Kiran. You have to work only in the file system in Hadoop. Yeah, you can use anything. You can use any CSV, any Excel, anything as a file system can be used. Fine, Kiran. Anything can be part of the file system. That depends on the use case, Kashish. So if you, without understanding the complete use case, it's really difficult to say. But this can be done without mouth also, actually. As there are multiple technologies running over Hadoop, so which technology we shall start work on professionally? So first you have to understand the complete Hadoop architecture, Gaurav. Then only you have to, then only you can understand the other technologies, how they run on top of it. So first you should be completely aware of, how Hadoop technology works. I just want to apply it. Okay, sir. The project with the real-time use case. Yes, Ravi. We'll give the project with the real-time use case. Yes, exactly. Can you give more details about the project? The project is basically we'll be providing a use case which is near to real time, and also we'll be guiding you on the same. So you have to come up with a solution for it. We'll make you to work on it so that you'll get a better understanding of how Hadoop is used in the real time scenario. That's the intention behind this one. When we send .csv input, what will the output assume? Like you can decide whatever the output format you want, Kiran. There's no such restriction in the output format. It's completely depending on what MapReduce algorithm we are going to write. Will it be doing tuning and transforming? There is absolutely no problem on tuning and transforming because this is big data, Kiran. This is extremely big data. You will never get a problem like tuning and transforming and all. It will scale up by itself to a very great direction. We are talking about 100 TB and petabytes of data. Tuning and transforming is for the something like database which cannot scale. Hadoop is something which can scale to a very great extent. Okay, fine, Kiran. So this is different. This is altogether a complete different technology. Okay. I hope Lognath answered your question, right? Okay, so fine, everybody. Then thanks for the session. What is the full form of Hadoop? No, it's not full form of Hadoop. Hadoop is just a name. That's all. It's a toy name of the founder. It's a toy name of the founder's kid. Okay. Yes, Chetna. Starting with the Hadoop architecture is always the best thing to be done. Yes, yeah. Next thing you have to go over the MapReduce algorithm and afterwards the pig and hive, the rest of the things. Okay, so thank you all. Thank you very much. More questions, please forward the same mail to the support, and thank you, Sridhar. And please forward the mail to support. Get in touch with support, and they will provide you all the details of what the course is all about and the complete course details. Thanks for the feedback, Manish, Sridhar. I request you all to fill the same feedback at the end of the class because feedback really helps us a lot. So please kindly fill the feedback at the end of the class, and also please get in touch with support on the same to get more details on the course. Okay, thank you, everybody. Thank you.